Hi, this is Nilton from craftofprogramming.com, and in this video of Intellij IDEA 2019.1 we are going to cover refactoring and code generation. Refactoring is obviously a pretty big topic. I've got here the Bible of refactoring from Martin Fowler. It's a pretty thick book, so we're not going to cover all of the possible refactorings. Just going to cover the highlights, things like extract variable, extract field, extract method, extract class, introduce parameter, for instance, and some of the productive tips of IntelliJ in terms of code generation.
Okay, so before we get started, just like to mention what is refactoring. So refactoring is basically the action of improving the design of a software system without changing what it does, without changing its functionality. So because of that, one requirement of refactoring is a very good test coverage. So you want to have good test coverage so that as you are going through the changes to improve the design of the system, you're not breaking it, you're not changing its functionality. And the actual mechanics of doing refactoring on a realistic code base are you run your tests first, you make sure that everything passes, and then you apply one refactoring, and then you run the tests again, and then you apply another refactoring, and then you run your tests again. Make sure that each and every refactoring that you do, you are not breaking the functionality of the system, you're not breaking any of the existing tests. Okay, so I have here a very simple class called forkBlur, and this basically uses the fork join pool to blur an image, and it uses obviously the recursive divide and conquer algorithm. It's a very simple class, and I chose this class because all of the code is in a single class, and as you will see, I'll be able to demonstrate some of the key refactorings that IntelliJ supports by working on this very simple class. So just to show you a little bit more what it does, so the main method, as you see, it basically loads a file, which is an image, creates an image object, and then it blurs the image object, and then it just writes the blurred image back out to a file. And the way it blurs is basically by using the fork join pool to basically do the blur. So I don't want to go into details about the actual blur algorithm. That's not the point of here. The point is to demonstrate IntelliJ refactorings. So notice that we've got here the main and the blur are static methods. So the first refactoring we're going to do is to basically move those to a new class. So as you can see here, we just have one class, which is the forkBlur. Let's create a new class. Let's call it main. And now let's go back to forkBlur and let's move those two public static methods to the main class. So most of the refactorings in IntelliJ are accessed by pressing Ctrl-Alt-Shift-T, and this is basically the action called refactor this. And this is nice because it's basically context sensitive. Depending on what you are selecting, you're going to have a context sensitive menu. Okay, so let's move the main method and the blur method to the main class that we just created. So let's select main and blur, and let's pick the main class, and let's move them. So now as you see in the main class, now we have the main method as well as the blur method. So now the forkBlur recursive action or task only has these three methods. So another thing we can do here is forkBlur. I usually don't like methods or with this long parameter list. So another refactoring we can do here is extract a parameter object. So let's give it a name, for example, context. And so let's create a new class and move the parameters. So here we're going to select the fields that we want to move. So with sort, start, length, and destination. Okay, cool. So now notice that the context class has been created with our fields, with the corresponding getters, and the fork blur constructor has been correctly refactored. Okay, so moving on, the next thing I would like to do is to extract a superclass that will contain the mechanics of the divide and conquer algorithm and let subclasses implement the actual algorithm. So if you take a look at the compute method, you will see that it basically contains the mechanics of the divide and conquer. So it just basically keeps splitting the work until it gets to a threshold where after which the actual work is done. So let's move all of these mechanics to a base class and let subclasses implement the algorithm. So for that, let me start to extract some methods here. So let's call this should compute directly. Let's just keep the original signature. Let's change this to protected. And because this method is going to be moved to a base class, it's still creating a fork blur, which is, a specific implementation here. Let's introduce a factory method that will encapsulate the actual, subclass. So let's do this. So before that, let me create the factory. So let's call it average pixels fork blur factory. Okay, now we have this class, this factory. Now that we have this factory, let's replace the constructor with the factory method and move it there. So now we have the factory here, and the basically all the places where the fork blur object is being instantiated have been changed or delegated to the factory. So one other thing I'd like to do is to replace this static method with an instance method. So just use this convert to instance method, and let's do a refactoring. So now if you go back to fork blur, notice that we are instantiating a factory. So we will fix this. Obviously we don't want multiple factory instances. Okay, so now that we have an instance method, let's introduce an interface here. So let's extract an interface. And as you can see here, there is nothing to show. And this is because the instance method in the factory is actually package private. So let's change the visibility to public, and let's do again extract interface, and now you see that the method is there. So let's make it an abstract method, and obviously let's give it a different name. Fork blur factory is a good name for the interface. So now if you go to super, now we have the create fork blur interface, which is implemented by the factory. So now if you go back to the usages of the factory, we still have the factory being instantiated. So let's fix that. Let's introduce a singleton, fork blur factory instance, and let's just do this. Let's make the constructor private. Okay, and now obviously all of the places where the factory is being instantiated are broken. So the way to fix that is, there are a few ways, but one simple way to do it is to basically do a structural replace. So let's replace structurally this code. So basically what we want to do is we want to find all of the usages of where the factory is being instantiated, and let's replace this with the instance. Okay, so let's find, and IntelliJ says that there are 4 usages. This is where the actual singleton is being instantiated. We don't want to change that. And this is the other 3 places, so let's select them and replace selected. Okay, so this concludes the part 1 of the refactoring video, which is split in 2 parts. Please refer to part 2 and last to finish. Thanks for watching, and as usual, if you found this video useful, please consider subscribing to the channel, give it a thumbs up, and also some suggestions on how to improve these videos moving forward. This is Nilton from craftofprogramming.com. Thanks for watching.